it's really so great to have all of you here, and I really appreciate you coming down here to do it. We, of course, very much appreciate that Damon Runyon Cancer Research Foundation has put together really an incredible panel with some of truly the most respected cancer researchers in the world.
I am so thrilled to have all of you here tonight for this program. We are at the Damon Runyon Cancer Research Foundation focused on supporting brilliant young scientists who have the potential to make breakthroughs in cancer research. We provide them with funding to be bold and to pursue risky and innovative questions that we believe are going to change the face of cancer.
During the course of a cancer, more mutations occur, creating this world of evolution in which tumors are inherently heterogeneous because every cancer cell has the ability to acquire new mutations and to unleash a battle among cells in the cancer to allow the most fit cells to dominate the cancer. So these are complex evolutionary systems that have the potential to evade therapies. And we need to understand that better.
There are many ways to treat cancer. And for many years, we focused on the tumor and how to get the tumor to get smaller or to remove it. And so these are very well known to many people: surgery, chemotherapy, radiation therapy, for some cancers like breast or prostate cancer, hormonal therapy, and then targeted therapy, as Harold referred to, which relies upon the identification of some abnormal genes that are causing the cancer cell to proliferate and giving a medicine that stops that incorrect circuit. This is what is known as targeted therapy that Chris will talk about. So those are all things that get at the tumor cell. The second is immunotherapy, which gets at the patient. I use an analogy that the immune system getting started is like starting your car. You need a specific interaction, like a key being inserted in the ignition. You need an accelerator pedal, which is that second signal to activate the T cell, and then you need a brake. And the Nobel Prize this year was awarded to two scientists that were studying two different molecular breaks that have now become targets for medicines that are effective treatments for some people with some cancers. This is just the beginning of this story, that we now know that this type of therapy called immune checkpoint blockade can benefit patients with some cancers, not all. We still have more work to do, and we still have some interventions that we need to use to make some cancers interesting to the immune system.
And so for those guys with slow-growing cancers, they're getting too much treatment. We're over-treating them, and they have unnecessary side effects. It's unnecessary cost. Whereas at the other end of the spectrum, we're still under-treating legitimately lethal cancers for patients that need more treatment. And so it's sort of into that spectrum of a clinical need that we can start to think about the genomic classification of this disease. And that's just the basic idea of looking at the underlying DNA abnormalities of these cancers and being able to separate them into distinct subclasses that are defined by their underlying features, and using that information to understand prognosis better, to understand our choices of management strategies, to identify specific targeted therapies for one subclass or another. And really all these things are the paradigm of precision medicine, picking the right treatment for the right patient at the right time. If we can think of this as sort of the whole space of prostate cancer, and that the majority of these cancers have certain underlying genomic abnormalities, and they have their own package of things that come along with them, where there are other cancers that are completely distinct from those, completely separate, molecularly completely different animals. And that really leads to the recognition that we're not dealing with one disease, we're dealing with a collection of molecular subtypes, and we need to think about things that way. And by thinking of these as distinct molecular classes of prostate cancer, that leads to the recognition that there's going to be distinct biology underlying each of these molecular classes. And that leads to the idea that there's going to be distinct therapies for each of these molecular classes.
There are a lot of ways in which the status of a cancer patient has been improved over the last some years. We're focusing here on some things that are clearly based on fundamental science and are perhaps most revolutionary in concept. But it is important to remember that other more standard parts of cancer treatment have also improved over the years. I want to thank all of you for listening. Time for dinner.